the weighted majority vote, are not really performing as well as many other models. One major reason for this is that we are considering few very weak models also and highly correlated model also, so that the problem with highly correlated models is that averaging or taking majority vote doesn't change anything. Problem with considering with equal weightage, the weak models, is that they end up decreasing the performance. Okay. Anyways, also this might have been a different case probably if we were working with some different data. Idea here is that the process of taking a simple majority vote or weighted majority vote should make sense. Does that make sense? Yeah. The performance is something which might be different considering the business problem that you're trying to solve or the data that you're trying to solve. But what I really like is, but okay, fine, before we go to blending or stacking, similar to the classification problem where we are considering majority vote of your class predictions, you can do averaging for the problems where your outcome is continuous numeric, the regression problems that you are considering, or where instead of hard classification in terms of 0, 1, good, bad, yes, no, you want probabilities of occurrences, you can average them too. Okay, and the case of the choice of models that you should average here is again the better if you are averaging models which are less correlated. Okay. Just the ideas in averaging and majority votes are similar, just that you have to adapt for the difference the way your outcome is. Okay. What we just discussed was simple bagging of models where you take the outcomes and do something with them. But as I told you at the very beginning that I'm not a very big fan of that. Instead, we are going to use predictions of these models, the different models which end up extracting different kind of patterns from the data. We are going to use their predictions as features for simple class of models. We will call them meta classifiers. Blending and stacking are, these are not very labels which everyone has agreed on. So you'll find when you're reading about them that people talk about blending and stacking kind of interchangeably at times. They will refer blending as stacking, stacking as blending. So don't read too much into the names here. But I will discuss the simpler idea first. There is, remember we have broken our data into train and test, and we are using test data to find out the performance of the models that we have been building so far. Where did I put the eraser? Oh, sorry. So what do we mean by using the predictors, or rather predictions from all these different sophisticated models as features? Instead of building your models and taking majority vote on the trained data, we break the trained data into further two parts. And then you build your first layer of models. The example that I've taken is I'm considering only one technique, which is GBM. You can consider many first layer models. You build your KNN or neural nets or random forest or any of these techniques that you use. You build models on this. So I will call it first layer model. Then make predictions on this guy. So let's say I build a GBM model. I will add a new variable in this data, call this VGBM, which is nothing but prediction of this on this data. Why did we break our data into two parts? Why not build the model on the entire train and then add the predictions to it? Mhm. Why not? Why have we broken our data into two parts? Why not build the GBM model on the entire trained data and then include the variable which is nothing but predictions of on the same data? Yes, avoid the leakage of information, right? Okay. Now that we have all the variables plus the prediction from GBM, you build your meta classifier on this, where you're considering predictions from GBM as one of the variables. And then you check its performance on the test data. Now, so the idea seemed fairly intuitive, right? You build models, sophisticated models on one part of the data, use their prediction on the second data, and use those predictions as one of the variables. There is no information leakage. This is easy to implement. We'll see in a minute. But here is the catch. When you are breaking your data into two parts, see this. Your first layer of model, your GBM or KNN or whatever the choice of models that you're selecting, never gets to see this guy. Meaning, you are not able to utilize the pattern which might be present in this data which you're not using for first layer models. Yeah? And same goes for the meta classifier. It doesn't get to see that pattern which was there. Okay? So what is the way out? Way out is crosswalk. Yeah?
But are we not bringing in correlation with the predicted values and actual labels that we have in the model?
I think that will be taken care of by the algorithms itself. So what if they are correlated? Consider it this way. You do include, transform variables, right? So if you are considering x as well as x square, they, in many cases, or x plus log x, any exotic transformation you can think of, in many cases they tend to be correlated, but you still use them in your model. Consider these as some transformation, result of GBM as some transformation which has a very exotic function which you cannot explicitly express. Yeah? Okay. So let's quickly implement this, and then we'll move on to how to take care of these this particular point where you are not making use of the data which you should have otherwise. We are breaking our trained data here again into two parts. And then I am making my layer 1 GBM model on first part of the data. Again, I got lazy and I haven't really tuned my hyperparameters here, but the idea should make sense. Whatever choice of parameters I am using here, these might not be, or they can be tuned to build even better first layer model, and eventually it will improve your performance of meta classifier which you use as a second layer. Okay? Now this code is nothing but a repetition of, as far as the syntax goes, the GBM model that we were building for majority voting. In next line, there should have been a space, sorry about this. Yeah. So in next, now this train B, which I haven't yet touched to build my first layer of models, I use in the first layer I use train A. Now in train B, I'm adding the predictions here. I'm not adding the hard predictions. I'm adding the probabilities. Okay? Why is that? Why I'm not adding the hard predictions? Why I'm adding probabilities? Yeah. Basically, probabilities are more rich in terms of information that they hold. When you take a threshold, basically you're smoothing out the information which is there. So better is to use the probabilities as features, so to say. And I do need to put this as well. I am including test data GBM, which is basically prediction of the model which I built on train A. Why am I doing that? Right, because we need variable which I'm including or I'm going to utilize that in building my model. I will need that for to make predictions as well, right? Okay, so that is clear. And then I am making a simple logistic regression model as a second layer on train B. Okay. If you recall, this was the performance of my logistic regression model originally, where the precision was this. Everyone knows, so if just to clarify, precision is basically how accurate your prediction is. Recall is how much positives you can capture. And F1 score is combination of both. Okay, and accuracy we all know. You can see here precision, recall, F1 score and accuracy, all of them have been improved when I use the simple blending, right? The precision score has gone to 0.52, recall from 0.60 to 0.73, F1 2.61, and overall accuracy has also seen slight improvement over what we had earlier. Yeah.
We have two different layers of models.
Uh-huh.
Assume the property of one is P and the other is some Q. So the eventual property will become P into Q, right? Always be less than either P or Q.
Sorry, I did not get that.
From one model, assume the property is P.
Mm-hmm.
From the second model, the property is Q. Then the
So you're not using just that. This is one variable with some other variables in the data as well. This is not a simple translation of decisions. You get that? Yeah. So GBM is one variable. You are utilizing other variables in the data as well. You are using, or rather, you are using the predictions from GBM as one of the variables with some exotic transformation. Assume that. Okay. Clear? Okay. Now, talking about stacking, although sometimes it's difficult to wrap your head around the idea. As we were talking, when I said blending results in not utilizing your entire data set, and your results might not be that good if you end up missing out on some crucial pattern which was there in train B or train A. Consider that, and it's not that these numbers 5 or 4 are not the hardcore pattern that you always use these many folds. This is just an idea. You can use 2 folds, 10 folds, is up to you. So consider that I have broken my data into 5 parts. The 5th guy I'm going to use for testing. Okay? When I'm building my first layer, I can build my model on these 3 chunks combined, right? And then I can make predictions on this guy, the way we did for train A and train B, right? Okay. Next, I can build my first layer model on this guy. Rather, these 3 guys taken together, and I can make predictions here, right? And then I can take these 3 and make predictions here, and similarly the remaining 3 chunks taken together, and I can make predictions on the remaining chunk of the data. What are we doing here? We are getting that out of sample predictions. We are getting those predictions using the GBM model on the data which was not utilized in the building model. You realize that we eventually end up utilizing the entire data. Okay. The second layer of model which I'm going to build on these 4 guys, these 4 chunks taken together, has access to still out of sample predictions of first layer of model, right? Is that clear? Any questions? Mm-hmm. Oh, sorry, don't get confused by these numbers. Let me call them both 1. So this is all of them, this is also 1, and the other 3 chunks that I'll take, let me point those out as well. That will be this, this, and this, I guess. Is that correct? Yeah, okay. So you are building your first layer of models considering leaving 1 chunk out, okay, and you are making out of sample predictions on the chunks that you have left out, okay, clear? So now I am at the stage where on this entire data I have out of sample predictions, so I did not have to break my data into 2 parts, yeah, and I can build. Now that I have that GBM variable, so to say, I can build the second layer of model. That can be any meta classifier. It doesn't have to be logistic regression. You can use layers of GBM and so on. And in fact, if you go through many solutions that people come up with in Kaggle, they end up using a lot of layers of models. Yeah, so I can build my this meta classifier on out of sample prediction, including other variables also. Yes?
So now we have 4 additional features that you created, right?
We have 1.
1 for each set of models, for each class.
Okay, let me clarify that again. I have just broken my data into 5 parts. I take these 3 guys, combine them, okay, and I build my GBM model, and then I make prediction on this guy. So in addition to all other variables, now it has GBM also, okay, clear? And then I consider these 3. So when I'm considering GBM model on that, when I'm considering that, I'm not using this guy again. Yeah? And then which is the remaining chunk now? This is confusing. This guy. This ends up having GBM predictions and so on. So eventually what we are trying to do here is get this out of sample predictions for all these chunks using the remaining 3. Okay, is that clear now? Yeah. So now that we have out of sample predictions to utilize in my second layer of model, I will do that. Okay. And then I build my first layer model again using all these 4 chunks taken together. Huh? No, second layer model I have built utilizing the out of sample predictions as GBM variable and the original data. Next step, I am going to build my first layer of model now using all 4 chunks. Previously built because we wanted to get out of sample predictions. Why am I doing this? Why am I now building my first layer of model again using all 4 chunks? And so that we can utilize this here. Okay. Now when I build my first layer of model, again it can be any algorithm. In this particular case we are considering GBM. It can be any algorithm, it can be many algorithms also. Mhm.
Won't that be overfitting?
Why will I not be overfitting? Because I'm not utilizing the the leakage of information is not happening in the sense that I'm not utilizing now the first layer of model prediction for fitting the second layer of model. Second layer of model was fit on out of sample predictions only. Okay, let me try to clarify that. So second layer of model was making use of the original data as well as the new variable GBM. Is that clear? Yeah. When it is making use of this variable GBM here, it was this variable GBM was dependent on the rest of three chunks. Correct? Now when you want to make predictions using second layer or rather the final model on the test data, the GBM variable here will be dependent on all four or rather rest of the data. Does that clarify? To an extent, yeah. Okay, cool. So I build my model again, the first layer model on all the four chunks and make predictions on the test data in order to assess the performance of the second layer or final model on the test data. And of course, this was one iteration. You can